the hell is space? What is this thing called space? And the first thing you have to understand is that this is not a trivial issue. In fact, the other day I covered time, and in comparison to space, time is a piece of cake. It's easy. I mean, it was hard, right, for all these people. They never defined time. But space has caused murder in mathematical physics. They have no idea to this day what space is. So we have to go very slowly. And one of the problems with space is that whenever people give an explanation of what space is for the purposes of mathematical physics again, oh man, they confuse it with distance, with location, with position, with place. They have all these confused. They start using, they immediately jump from one subject to another without telling you what space is. And they start analyzing position and distance traveled, location. They start in other subjects that have nothing to do specifically with space. They never define space, and they're already moving on to other subjects. And that has happened throughout history. Here are the famous words with which they confuse space, or which they introduce whenever they try to explain something about space, specifically what space is or a definition of space. These are the words that are always introduced in there, which have really nothing to do with the subject at hand. They have nothing to do with telling you what space is. Okay, here they are. Okay, we call them the fundamental concepts that have stumped and baffled the mathematicians throughout the ages. And again, space is one of those words that's confused with position, which they've everyone from the Greeks all the way to Newton called place. Okay, and they I think Newton was the first one to try to separate place from position. Okay, I don't know if Aristotle did that as well, but point. What is a point? Well, it's a location. What is a location? It's a dot that you put to represent the position and blah, 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 blah. So it's, and again, a point is one of the components of a line. What is a line? Is it a stick? No, it's a bunch of locations, meaning an itinerary, and so on and so forth. So again, they bring these words to try to explain space in the context of trying to elucidate what space is. Distance traveled. And in distance traveled, you have, the qualitative notion and the quantitative notion. Displacement, that's a quantitative notion of distance traveled. Okay, distance traveled, I mean, you can travel a certain distance. That doesn't mean you're going to measure and say this is so many meters that you traveled. You can just say there was this much separation between your starting point and your ending point. And you have no number, you just say that's separation. Okay, so distance traveled could be, from a qualitative point of view, could be just distance. It could also be displacement. So we separate that as a distinct concept. Line, what is a line? Motion. That's what it is. The line, they put these dots, they put the stick. And what is that? That's just to represent the one-dimensional what? Itinerary. Like if an itinerary has dimensions. What is it? Length, width, height. What dimension does an itinerary have, a trajectory have? And length, dimension exist. They talk about whether space exists or not. Why do they do that? Well, very simple, because they never defined the word exist. Does God exist? Well, yes, some people say, and others say no, and others say maybe. And none of them ever defined the word exist, so we don't know what they're talking about. And they don't know what they're talking about. They go around in circles. They're known as atheists, theists, and agnostics. All three of them go in circles because they never defined the word exist. And yeah, you have incessant discussions in circles when you don't define words, key words that make or break your arguments. Object, what is an object? Well, it's a thing, it's a figure. So is space an object? Is it a thing? And man, that already, if you look at history, especially the Greeks, it's just mind-boggling. They just went around in circles on both object and exist. And then they never defined the word concept. And so the question is whether space is a concept. Is an object a concept, like some people say, Yeah. So keep in mind all these words, because we're going to go through them right now in one way or another. And so that's going to give you an idea what the problem is, why they've never been able to define space per se. And here you have it. In mathematics, right, what they've done throughout these years is consider space to be a physical object. They never distinguish between space and object, space and things. Okay, they talk about space being 3D, meaning that it has dimensions. They also equated it with the ether. And the ether was essentially a bunch of particles, according to the Greeks. This region between, especially in the case of Aristotle, but there were different notions. But in his idea, it was this substance, this thing that existed between the moon and the earth out there, especially above the fire zone that circumvented the earth. And so this ether was, again, it stands for air. So it's a different kind of air. It's like the air that the gods breathe. And of course, they imagined it as being made of particles. And so that's what the ether was, a bunch of particles that were out there outside the reach of human uh, understanding. Okay? And then there's also this notion that space is a container where all these particles are in. Okay, so you have the ether being equal to space, and then you have also the ether, the space being the container of ether. Like if it's a container of a bunch of bunch of marbles, or a sand beach, or whatever, a sandbox. Okay, just a bunch of grains that are somehow trapped within space. And the issue there again is what separates one grain from another. What are you going to call that? And yeah, that's called space in that case, and you still haven't answered what space is. Space has been equated to a field, which is also considered to be a thing by the mathematicians. Why? Because they vibrate them. They say that space moves. In other words, this field moves, vibrate, and that is what space is, a field that's vibrating. It's also a particle, so space is particles. Space is also equal to energy. They say that you have all these particles, energetic particles coming in from the void, and it's just pure energy that goes back to being energy when the particles recombine. Okay, so space has always been considered to be a thing. They use adjectives such as finite and infinite, which are only applicable to objects, and these are the ones that they use to qualify space. Is space finite? Is there a border? Does it have a surface? If so, what's on the outside of it? And if it's infinite, well, is it a thing? Because all objects are finite. And so what is space? If space is infinite, what kind of object is it? What kind of thing is it? And that's why we need to define these words, what a thing is, what a concept is, and so on. Okay, then they say that there could be parallel universes. And this is really surrealistic because they separate these universes always in pictures using some black stuff. And they insinuate that black stuff is space, which is actually what's contained within each universe. So you have a universe that has space, time, and matter within it, but all these universes are separated by space. Yeah, sure, it makes a lot of sense. And then they say space was created at the Big Bang, like if it was a thing that was created. And yeah, you can imagine poor old God, trying to create space. Hopefully he was successful because until then he had no shape. He had nothing to give him contour. So hopefully God was quick at creating space. That's my sincere wish for him. Okay, so where do we go to these people? Well, we go back to the days of the Greeks because they essentially debated all the issues that we still have today. So if you go to the age of the Greeks, philosophers as they're known, you get an idea of what we have not made any progress on in the last 2,500 years. We have the same exact questions today and the same debates and the same arguments. And it looks like people don't read Greek history, at least the philosophers, and that's why they repeat the same arguments. Because if they went back and they read what the Greeks wrote and what they talked about, they would find out that those same subjects are alive and well today. We have not progressed a single iota in 2,500 years. Okay, so here it goes. This is Mr. Parmenides, and he wasn't the first, obviously. He just made a couple arguments that are interesting to start our conversation today with. Okay, here it is. And he is quoted here because we lost a lot of material that belonged to Parmenides. But here is one fellow, and his name was Aetius. And he said, this is how he quotes Parmenides or summarizes, Parmenides' cosmology. Okay, the air has been separated off from the earth, vaporized by its more violent condensation, and the sun and the circle of the Milky Way are exhalations of fire. Okay, so they thought there, you see that fire there, and you see the earth surrounded by water, surrounded by air, and surrounded by fire, and the black stuff there, that was the ether. Okay, that was outside our reach. Okay, a bunch of particles that somehow filled that gap between the moon and us. The moon is a mixture of both earth and fire. Okay? The ether lies around above all else, and beneath it is ranged the fiery part, the fire there, right? Which we call heaven, beneath which are the regions around the earth. This was the notion that Parmenides had of cosmology, and this is how we end up with his notion of space. Okay? He says, really, there is no such thing as space, because if there were, then we'd be in a lot of trouble because it would mean that space is a thing. Okay, and listen to his argument. He says, assume, let me remove this here. He says, assume, this is his train of thought, okay? Assume there exists a void, meaning space, nothing, okay? Void is equal to nothing, right? But nothing cannot exist. Something can exist, but nothing. What do you mean nothing exists? No, nothing cannot exist. Therefore, there is no such thing as void, as nothing. Because if there is something called void, you're essentially turning it into a thing, so to speak. And if it's a thing, then it exists. But nothing does not exist. And if nothing does not exist, then there is no such thing as void. That was his line of reasoning, and so or lack of, you could say. So he was under the notion that there is no such thing as change. There's no such thing as motion, because he concluded that something cannot move into a void because there is no such thing as a void. Okay? Because if there were something as a void, it would exist, and if it exists, then it's not a void, because the void is nothing and nothing does not exist. Okay, that was his train of thought. And indeed, he says there's always something there. There's air, there's water, there's light. There's always something in that region you think has a void in it. There's something there. Okay? So anyways, this was his train of thought, okay, his way of thinking. And he was opposed by the atomists like Democritus and Leucippus, who were in Abdera in Thrace. Okay? And they didn't pay too much attention to these guys. They really brushed them aside. He says, motion requires a void. In other words, you cannot conceive of motion without a void. Somehow, things have to move into somewhere. And he says, observation proves that there is motion. Therefore, there must be a void. And so this is how their argument for brushing Parmenides and his disciples aside. He's saying, there is motion and there had better be a void because you have to be able to move into, one of these voids in order for there to be motion. And so these were the arguments that they raised. And we'll see that they're still alive and well even to today. People still debate these things. Okay, so a century later, you have Aristotle come in, and he puts his grain of sand, he puts his piece of mind in there, okay? And I'm not going to go through Plato and some of the others that also discuss this issue, okay? Just trying to hop so that you get the big picture here. And so Aristotle says, the investigation of similar questions about the void also must be held to belong to the physicist. Now, there's a physicist has to look at this issue. It's a subject matter of physics, namely, whether it exists or not. Does the void exist or not? This was one of the issues that kept the Greek so-called philosophers up at night, okay? And how it exists or what it is. So they were trying to figure out what the void is. Does it exist, okay? And if it exists, again, what are you talking about? What is this thing you call void or space, okay? And the problem is that Aristotle, especially even people who came after, they started confusing or discussing space in terms of place. The word they used was place, or it was translated as place. If you look at it, it's, as far as I'm concerned, it's the position of mathematics today. The word position essentially replaced the word place. Newton says one, as we're going to see in a minute, that position is just qualitative, while place is quantitative. That's the way he looked at it. But what is place? Place is the volume occupied by an object. That's the notion all these people had. And so they started talking about whether an object occupies a volume. And what is the volume? It's the object itself. Because it turns out the volume happens to meet the same shape as the object. Okay, so this was their notion. What this has to do with space, like, in the universe, the space out there, the black stuff, I don't know. But their reasoning all had to do with local stuff. They said, if I take a ball and I move it from here to there, like I move it in water, well, we can see how it displaces water. Okay, so now I move it to air. Does it displace air? And they concluded, yeah, it displaces air because the air moves somewhere else, and now that object occupies that volume of air that air occupied before. And from that, they started trying to figure out whether there was a void, what was it that the ball occupied, and whether before it occupied that, it was filled. And whether it was filled or not, can you say that the void exists, that place, that location or that position, that volume, does it exist on its own before the ball occupies it? Those were the issues. And with that reasoning, they were trying to figure out what space is out there, the universal space, which in the case of Newton, he's going to refer to that as absolute space, and he's going to refer to this stuff over here, really, the way I look at it, okay, as the relative space. And that's also what Einstein's going to later on take over. He's going to say, oh, relativity, rings a bell. Okay, so he says, those who hold that the void exists regard it as a sort of place or vessel which is supposed to be full when it holds the bulk which it is capable of containing. So it's full when it's got the thing that occupies that volume. Okay, that's what he's saying. Void when it is deprived of that. Now it's a void. Okay, so if you deprive it of that thing that you put in that volume, now you have void deprived of the object that occupies the void. In other words, now he's saying, is there such a thing as a standalone void before anything occupies it? That was the issue, okay? As if void and full and place denoted the same thing, as if they were all synonyms. And again, he's saying, is the void the same thing as the volume? And is there such a thing as a volume without something occupying that volume? Okay, that was the issue. Those who try to show that the void does not exist do not disprove what people really mean by it, but only their erroneous way of speaking. In other words, he thought they were just playing semantics when they played all these little tricks. And he says he's going to clarify for you, what really is this void thing and whether it exists or not. Okay? He was on top of things. Okay, and so here he goes. He says the void is thought to be place with nothing in it. Okay, clear. The volume. The reason for this is that, and here it's interesting that he's got the definition of exist almost at his fingertips, okay? People take what exists to be body and hold that while everybody is in place, okay? So he's saying that what is exist? It's body that has place, which is not totally correct. That's position, that's volume. But if you look at it, he was very close to saying body that has location. So interesting. And they would have missed it anyways, okay? Void is a place in which there is no body, okay? So that where there is no body, there must be void, okay? Everybody, again, they are supposed to be tangible. So he's thinking that body is that which you can touch. Otherwise, it's not a body. In other words, again, they had this see-touch notion and not the notion of shape, which is how Euclid is going to define figure, saying, it's that which has a boundary. What is it? Definition 14 in his first book. And then you say, well, okay, what is a boundary? And then you go back to definition 13 and says, boundary is the cover of a figure. So we have a circular set of definitions. Figure is that which has boundary. Boundary is that which is the outside of a figure. Great, we learned a lot. But that would have been correct for, or close enough for what an object is. But here he's saying, no, that's that which you can touch. Okay, so again, they had no idea what an object is, first of all. And second, they never discovered how important defining the word object is for physics. Okay, and they never used these definitions anyways. Okay, they just casually used the see-touch definition. Okay, so that's big problem right there. And so he says, so that where there is no body, there must be void. Okay, everybody, again, they're supposed to be tangible. And again, that's not the definition of body. And of this nature is whatever has weight or lightness. Again, he's saying that anything that has weight, mass today, I guess, whether it's heavy or light, he says that's also a quality or a property of objects. And hence by syllogism, what has nothing heavy or light in it is void. So void has no shape, you can't touch it, it's got no weight, etc., etc., etc. Okay, so what is the problem here? Okay, he continues, he says, void must, if it exists, okay, he's talking about the existence of void, be place deprived of body. We have stated both in what sense place exists and in what sense it does not. It is plain that on this showing void does not exist, either unseparated or separated. The void is meant to be, not body, but rather an interval in body. In other words, void is what separates a body. That's what he's saying, okay? It's what creates a discontinuity. This is why the void is thought to be something. Okay, so again, the problem with his whole reasoning is that he's not really addressing what space is out there. He's just looking at position, which he calls place, and he's saying place is void, a chunk of space. He's talking about that little chunk. He's talking about the volume where he's going to put a thing in there. Okay, and he says if we take the thing out, do we still have the volume there, standalone volume with nothing in it? And again, that has nothing to do with space because it cannot even be conceived. I mean, what sense does it make to talk about a volume of space within space? This is where they got caught. This is where they made their error. Because if space is this whole thing, you got to talk about space and not tell me about what happens at the microscopic level here on Earth compared to space out there, right? Talking about volume being occupied by an object, and without the object, you have a volume of space in space. Yes, the volume of water in water. What's volume of air in air? What is that? You're going to kind of encapsulate it with what? How do you separate space from space? How do you separate void, place, volume from infinite space, right? I mean, if that's what space is, infinite, an infinite object or whatever. So this is where the irrationality stepped in. Okay, they never figured that out. Okay, so what does good old Newton say? Okay, he comes in a few centuries later, and again, we're going to skip Descartes and some of the other guys in between. He starts in his scholium. He says this right up front. He says, I do not define time, space, place, and motion as being well known to all. Now, what a way to start his book. That's at the beginning of his book. So he's not going to tell you what space or place is. And then he does. Gives it the best shot he can. And what he does is separate absolute from relative space, whatever that means. I mean, I thought space was space was space, and now he's going to separate them. Why? Because he's going to be doing numbers on them. He's going to talk about distance traveled. He's going to talk about location, actually position, which is in mathematics. It's mathematics, really, because it's mathematical physics. They're all synonyms. You know, motion and position and displacement, all three of them are synonyms. They don't use the word motion, they use the word displacement. Why? Because it's a number placed on motion. And what is position? The same thing, exactly the same thing. Position is motion. It's how many miles, how many meters, whatever you move from A to B. They want to know an amount, which is what they're going to be putting in an equation. What is the position? Well, it's so many meters here and so many meters there. What does it mean? Distance traveled. So there's no difference between distance traveled, motion, displacement, and position in mathematics, in mathematical physics. Only I must observe that the vulgar conceive those quantities under and no other notions but from the relations they bear to sensible objects. Again, touch. Okay, so he's comparing that to sensible objects. Okay, and thence arise certain prejudices, for the removing of which it will be convenient to distinguish them into absolute and relative, true and apparent, mathematical and common. Okay, he's got to separate these things in mathematics, essentially. Okay, and so here he continues. This one there. Hold on. Put it up here. So he defines place here, okay, to show you that it's not the same thing as position, which I think they are, but he thought they weren't. And he said place is a part of space which a body takes up and is, according to the space, either absolute or relative. Okay, so he's trying to separate this word place from position, essentially. I say a part of space, not the situation, nor the external surface of the body. For the places of equal solids are always equal, but their superficies, by reason of their dissimilar figures, are often unequal. So he's saying that, you know, he's got to compare here position against place, essentially. Positions properly have no quantity, nor are they so much the places themselves as the properties of places. Okay, so I think he just complicated things because he's trying to create a numerical space and differentiate that from qualitative space. And of course, it doesn't stop with Newton. When you work your way forward, you get to Einstein, and he's going to pick up more or less on the same notion, but he's going to go more with the Aristotelian notion. And this is what Einstein has to say. Okay, this is his notion of space, which we all know quite well today. And this is from NASA, so it's official, okay? Einstein thought space and time were intertwined in an infinite fabric like an outstretched blanket. Canvas, fishnet, okay? Fabric. The massive objects, such as the sun, bends the space-time blanket with its gravity. Okay, we've all seen the picture. I've shown it several times. Here it goes one more time. Okay, there it is. That's what Einstein had in mind. He's saying there's a blanket, there's a canvas, fishnet, whatever you want to call that, fabric. Okay, and the sun weighs it down, and the Earth cannot escape the solar system because there's a wall of time, curved wall of time. I don't know if you see it there. There's the moon also going right through the wall. Okay, why? Because the moon circles the Earth, but the Earth is weighing down its own canvas. But the canvas of the sun encapsulates the Earth, because the Earth is rolling around that canvas, and because it's weighed down, it also throws the moon around itself. And so we have a problem where the moon somehow goes through the wall of time that the sun creates for the Earth. Okay, so this is a contradiction, so realistic. Okay, and here you have the big picture. This is the official picture. Okay, again, we have there the Earth moving the moon around itself. This is the notion that they have. This is the explanation, the physical interpretation they have for gravity. Anyways, what we have from Einstein is the warped canvas version of space, and it's somehow blended in with time. It's warped, and that's what prevents the Earth from flying out of the solar system. These are the explanations we have today. So what is space? Well, space is some kind of fabric. It's a thing. So we have all kinds of things, and space is also a thing. There is no such thing as nothing. And that's a little counterintuitive. There's no such thing as a nothing. And we kind of agree with that. Yeah, there is no such thing as nothing because nothing is a no thing. And so the question is, there is no such notion as nothing, as void, as vacuum in mathematics. That's the issue. So today we've ended up in many ways like they ended up with, like the Greeks started, 2,500 years ago. They started debating what is space. And they said there's no such thing as space because if space is a thing, then it would exist. Okay, and so it's really nothing. But then what is that volume that an object occupies? Well, that's a thing. Okay, so there is no such thing as no thing. Okay, as a empty volume out there, it's always a volume that is a thing in itself because there's always something in it. And so there's no such thing as nothing, no such notion as nothing. And the relativists have ended up with the same notion. They said today there's no such notion as nothing in all of mathematical physics. Okay, so we ended up where we started, at least the mathematicians ended up where we started. Okay, so here we have this notion of the definition of space today, and it is that space, the boundless three-dimensional extent, blah, 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 continues. It's an extent. That's what the Wikipedia tells us. So what is an extent? Well, you look it up and it says the space or degree to which a thing extends, length, area, volume. So that's great. An extent is an extent of what? Of space. And I thought space was the extent, so an extent is space. Okay, great. Okay, we learned a lot. And there's another definition, that's in the dictionary.com. Space, the unlimited or incalculably great three-dimensional expanse. What's an expanse? An uninterrupted space or area-wide extent of anything. So we're back to synonyms. Space is an expanse, which is an extent, which is a space. Great. What have we learned? We have Mr. Robert Laughlin, and he's a, He's a Nobel Prize winner. And here we have it. This is what he says. The modern concept of vacuum of space, meaning space, right? Confirmed every day by experiment is a relativistic ether. But we do not call it this because it is taboo. So after 2,500 years, yes, confirmed. Space is ether. Space is where we started off. We haven't changed one single iota. We haven't changed a single bit in our notion of space. Mathematical physics, I mean, okay? So what have we learned? Well, nothing really. We haven't learned much from the mathematical physicists in 2,500 years because now we have the same space, the ether, the thing, the object that the Greeks started out with or debated from the start. What do we call space under science? Here it is. Okay, here's the definition. Definition of science. We have object, that which has shape. Space, that which doesn't have shape. See how easy it was? Hopefully nothing and something are antonyms. And there you have it in those two definitions. Nothing is that which has no shape, and something is that which has shape. And yeah, one is an antonym of the other. And so we have solved the riddle finally. What space is, it's nothing. What is nothing? That which has no shape, which is an antonym of something, which is that which has shape. See how easy it was all along? Can you talk about the existence of space, of nothing? Absolutely not, because exist, and we'll get to that later on, but exist is an object that has location. It has to be an object, it has to be a thing, it has to be something. Nothing is not something. Nothing is the opposite. It's an antonym of something, and you need a something to have existence. So you cannot talk about the existence of nothing. We're done.